Okay, so now let's look at the mean versus the median. We already figured out what the median is. The mean, just an average. So you know how to calculate an average, but really in statistics, we're not just interested in calculating things. We're interested in comparing how things work. The mean and the median attempt to find the center. So the question becomes, what is the center? So if I were to ask you, start digging really hard, maybe you would say, well, it's typical, right? Common, maybe you would use these words. Maybe neutral, I don't know, trying to think of different things you could say, middle ground. So calculations are not just calculations. If you cannot interpret them, a summary of what it's supposed to give you or have any clue what it is, then it's pretty much useless. So the mean, again, is known as the average. Just one time, go over that. The sample mean is symbolized by its X bar. Really, again, this is the sample mean. It's just the name of the variable with a bar over it. And we usually use lowercase. There's actually a whole, we'll get to this, but when you're just saying this is the value of a particular sample, we use lowercase. So it's X bar, what if we could use different letters? We use Y bar or, like M bar or what, so whatever it is. And again, I said lowercase and then something capitalized. So, but usually when we have no, like algebra, we use just the letter X, and that's why you see letter X being used all the time. The calculation of the sample mean is symbolized as, again, X bar, and the equation represented as the following. So I'm going to make this out. So X bar is going to be, this is a data value, sub 1, plus the next data value. So what this is saying is the variable for our data, we'll label that X. This is the first data value, second data value, and so on. The third data value, keep adding them up until what? Until we reach the nth data value, and then divide this by n. Now, also you'll see this notation. It's called summation notation. And this, what I wrote, will be labeled as sum, the variable X, and the little sub I just means you're going to sum all of them. And then at the end, divide by n. This used to be more written with a little more detail. It would say start where, like I equals what, and end where. So this is usually here, start your start and your ending. But for statistics, it's always going to be the same. Start with number 1, end with number n. So then the little reference of where to start, where to end is sort of eliminated because we're always doing exactly the same thing. So the symbol, this thing is it's a really Greek letter. It's a Greek letter. Capital sigma. And it means to sum. That is what that symbol represents. And you see sometimes software with that symbol on it just means that it's about to add your data value. So calculate the mean and median. So let's just do this fast. The mean is just exactly what you think it would mean. It's going to be 34 plus 38 plus 39 plus 43 plus 45, and divide that by 1, 2, 3, 4, 5. There's 5 data values, so my n is 5. And when I turn that into my calculator, I get 39.8. Great. And there you go. That's the mean. That's the average. No big deal. But the median, well, again, the median, just to go through the position thing, position, even though we can see it right away, I'm just going through the motions. Position of median is going to be 5 plus 1 divided by 2. Again, notice it's an odd. So in this case, I get 3. And I can see that really from the start that 39 is my median. Notice it divides the data in half, 50% or below, 50% above that number. So the median equals 39. So notice the two numbers are pretty close. So this actually tells me something when that happens. Let's see what it does. Let's do this again, but now I'm going to calculate the mean and median of this data set. So again, notice it is again 5. We're really comparing and contrasting situations, really. That's how you can start making a sense of the different formulas, how they work. Well, notice what we've done is the same data set, except I have replaced the 145 with 150. In that case, notice, because there's still 5 data values, and all I've done, and it's supposed to be the middle, the median is not changing, right? So one thing we notice immediately that I have changed one number that happens to be at the end here, but unless that number I changed was the median is not changing. So notice the median, one characteristic of the median is that The median does not rely on the values of these numbers, any of them. The only thing the median relies on is position. That's all it is. So as long as it's in order, it finds the center position. Well, what happens if I do the mean? Well, you start seeing that what is the mean? Let's talk about that for a second. I like to think, well, I don't like to think of it. It is. So when I divide this again by 5, what it happens, I get 60.8. So by replacing 45 with 150, what have I done? I've increased the value of the mean. Now, here we go. So what is it that we want to be true? Well, the mean or the average should be typical, common, neutral, middle ground, something that somehow captures the data. Now I look at this data about 60.8, and I can see that it's wedged here between 43 and 150. I don't know, is 60.8 really the center, the common, neutral, middle ground? Does it capture the essence of this data? Because, well, the majority of the data is these 4 numbers. So no, this is really pushed off to one side. So it maybe doesn't really capture the center. So what is the mean? A way to redistribute all the values evenly between 5 things. So what this does is think of it like the wealth. I can think of this as money. Somebody has $34, $38, $39, $43, $150. And now we're going to redistribute that amount of money evenly among the 5 participants. So then that would mean that every single person would get this amount. So if I were if I take now 60.8, 60.8, 60.8, 60.8, 6.8, and divide it by 5, what do I get? Well, 60.8. But again, I have redistributed. That means that the sum of these numbers is the same thing as the sum of these numbers. So I've redistributed the amount. Sorry, I'm off screen. Did not realize that. So I have redistributed all that. I guess if this is money, that wealth. The mean tries to redistribute evenly. The median doesn't do that. The median just says, you find me the center number. So half the numbers are below and half are above. So now you have to ponder the meaning of the median and the mean and what it can tell you. One thing that it also tells me, as we'll see, is that the difference between this, you'll notice, because this is number so much bigger than the 39, it tells me that there's some data values in the upper end that are more extreme, further from this value. While here, because these two numbers were practically the same, it means that this distribution of numbers is more symmetric. That means, again, that it's somewhat evenly distributed on either side of, in this case, the median. But the median now is 39, here is 60.8. The difference just telling me that around the median, the distribution of numbers is not so even. Type of the mean and median of this set. So again, there's only 5 numbers. So I'm not going to speed this up a little bit. We know immediately, I can see this, that the median equals 39. As a matter of fact, what have I done before? Now I'm changing this value. So I'm changing that value, the other extreme. I could have changed this value, but I didn't, just to make it a little more obvious. So what does that mean now? Add these numbers up. And I get the number 33. The median hasn't changed. It's 39. The mean now is lower than the median, 33. Not too far apart. But again, that's just telling me now that the distribution around the median is not that evenly distributed as well, but not so bad. Not like the previous example that we just did. What about this one? Calculate the mean and the median of this. So again, there's n is equal to 5. So I know immediately that I need to just go to position 3, sorry. So the median is 0. Again, there's just a small number. What about the mean? Well, I mean, you can start seeing that this data is perfectly evenly distributed around the median. So if I were to add these numbers up, notice 4 plus -4 plus 4 is 0. -6 plus 6 is 0. 0 plus 0 plus 0 is 0. 0 divided by 5 is 0. So the mean is 0, the median is 0. How did that happen? Well, if it's perfectly distributed around, notice 2 away, 2 away, 6 away, 6 away. So if that happens, of course, the two sort of cancel each other out. So, but that could also be true if I were to do the following. So for example, let me just break this up. And instead of my data set being this set, I'm going to add 4 to everything. Add 4, -2. Add 4, 0. Add 4, 4. Add 4, 8. Add 4, 10. So in this case, notice the median equals 4. But what have I done? I have just evenly, again, all I did was add. So what's going to be the mean here? Well, everything is perfectly distributed. This is 4 away. This is 4 away. This is 6 away. This is 6 away. So in that case, because everything is perfectly balanced on either side, so notice 4, 0 plus 8 is 8 divided by 2 is 4. Negative 2 plus 10 is 8. 8 divided by 2 is 4. But again, so everything is sort of adding, just like here, you can see how quickly it canceled out. It's sort of canceling out here because you're going even. So the median, the mean, and you can try this yourself, just add these numbers and divide, will be 4. I'm not going to do it because I ran out of room here, but you can try it. Add these numbers, divide by 5, and you'll get 4. But again, it's because it's evenly, perfectly symmetric. So if the median equals the mean, what does that say about this distribution of data? It is perfectly symmetrical. So we're going to end it with this. Resistant measures, something that's important in statistics because we want to, again, know how the distribution of the data is affecting these numbers and what that could that possibly, how we could possibly interpret it. So measurements have characteristics, and one desirable characteristic is the ability of the measurements to resist changing significantly. Again, notice this vague word, changing significantly, if outliers are present in the data set. Note that we use vague terms such as significant, as each situation is judged differently. Is the median a resistant measure? As we've seen, though, if we've changed each end, the median never changed. Yes, the median is resistant. It resists you changing values. All it cares about is the position of the center. You start changing values and it resists, especially if you introduce outliers. Outliers, of course, are at the ends somewhere, so it doesn't affect the center. So it's perfectly set. Is the mean resistant measure? And you can see the answer is no, because the mean, if you start changing the numbers that are more extreme, I changed the ends, but it could have been this one as well, then all of a sudden it's not going to resist. The mean gravitates towards the imbalance of the numbers. So if the imbalance is to the right, then the mean will go to the right. If the imbalance is to the left, then the mean will go to the left. And as you can see, if the balance is perfectly, it just becomes the median.